So like I said, today is all about story problems, and you just have to determine, do you have to find the distance? Do you have to find the midpoint? Maybe they're asking you to find more than that, especially when we look at your assignment packet here in a second. So example 5, in the directions it actually says find the distance. So we will be using the distance formula. It says a pitcher throws a ball to a batter. So here's your pitcher. They're throwing a ball to the batter, who hits the ball to the shortstop. So the pitcher throws the ball to the batter, and the batter hits, ooh, that's not a very good straight line. We'll pretend that's really straight. Hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answer to the nearest tenth. So what they want us to find is what is the distance from the pitcher to the batter, and then what is the distance from the batter to the shortstop. So you're going to have to actually find two distances. In order to find the distances, what do you need to know first, or what do we need to figure out? What do you need to find the distance or to plug into that formula? We need to find the coordinates. So they don't give you the coordinates, so we have to figure out what the coordinates are. The batter is the easiest. The batter is at 0, 0. The pitcher from 0, 0, you go right 5, up 5. So the pitcher is at 5, 5. And then the shortstop is at, from 0, 0, you go right 5, up 10. So the shortstop is at 5, 10. So we have to find two different distances, though, in order to figure out what the total distance is. So we're going to start out by figuring out what is the distance from the pitcher to the batter. Figure out how far the ball traveled from the pitcher to the batter. So we're going to use, the pitcher has the coordinates 5, 5, and the batter has the coordinates 0, 0. So 5, 5, I'm going to call my x1, y1. 0, 0, I'm going to call my x2, y2. And those are the values that I'm going to plug into my distance formula, which is up on the board. And it'll stay there. So to find the distance equals, and you put a big square root sign, and then there's a parenthesis, x1, which is 5, minus x2, which is 0, squared, plus, parenthesis, y1, which is 5, minus y2, which is 0, squared. So that's what I get when I actually plug it in. This is the point yesterday that if you didn't have this written out and maybe you had it wrong, this is like I made people go back and rewrite it. Because sometimes if you're subtracting, these ones don't have any negatives, but the subtracting a negative really got people good yesterday. So then we simplify this down. So I have a big square root sign still. Order of operations says to do what's in parentheses first. So in parentheses, I have 5 minus 0, which is 5, squared, plus, in parentheses, I do 5 minus 0, which is 5, squared. Then I do the exponents. 5 squared is the same thing as 5 times 5. It's not 5 times 2, it's 5 times itself. 5 times 5 is 25, plus 5 squared is 5 times 5, which is 25. Then I do the addition. So then I get square root of 50. And now I actually have to plug this in. Square root of 50. So on my phone calculator here, I'm going to type in 50 and then square root. And this is probably the same problem as your same square root from your worksheet. I would round it to nearest tenth. It wants one decimal place, so this would be 7.1. So that's one of my distances from the pitcher to the batter. But it also wants from the batter to the shortstop. So we have to find that one now. Put a little bit of space here. So now I need to figure out what's the distance from the batter to the shortstop. So the batter has the coordinates 0, 0, and the shortstop has the coordinates 5, 10. I'm trying to keep this as organized as possible. As you can see, there could be many, many places for this to get kind of yucky and messy and all messed up and everything running together. So if I try to keep it as kind of organized as possible, it might make it a little bit easier to understand what's going on. So I'm going to label my points. The batter is going to be my X1, Y1 in this case. My shortstop is going to be my X2, Y2. And now that I have my coordinates, X1, Y1, X2, Y2, I can plug into the distance formula again. So distance equals square root 0 minus 5 squared plus parentheses 0 minus 10 squared. Then I simplify what's in the parentheses. 0 minus 5 is negative 5 squared plus, in parentheses, 0 minus 10 is negative 10 squared. So now, when you square something, you're taking that number and multiplying it by itself. The main thing, especially when you have negatives, is you need to remember that when you square it, you always get a positive. So if I take negative 5 times negative 5, I get a positive 25. If you're going to plug these into your calculator, you have to be really, really careful. And if you're going to plug it in, there's a parenthesis around the negative 5, and then the square is not inside those parentheses. It's on the outside. So that's 25 plus negative 10 squared. So negative 10 times negative 10 is a positive 100. Then I add those guys together. I get 125. And then I have to take the square root of 125. Holy moly. All right, so 125 square root, and I get 11.2. So I found the distance from the pitcher to the batter. I found the distance from the batter to the shortstop. So the total, if I add them together, the total is 11.2 plus 7.1, so 18.3 units. But that probably doesn't make sense. Like, they're not going to go on SportsCenter and say that a ball traveled 18.3 units because that's how you measure on a coordinate plane. If you look down here, in every graph, there's usually a key. And it says that for every unit, it actually is 9 feet. So 18.3 units, let's see, 18.3 units is the same thing as 164.7 feet. So that ball traveled a total of 164.7 feet. That's a big problem right there. That's a good one. That's a good quiz one right there. No, please no. Please. So really, the hardest part still, though, on these is just plugging into that distance formula. All you're doing, again, today is plugging it in. Any questions on this one? Okay, grab your assignment packet out. Turn to page 11. We're going to do one of your assignment problems together. Okay, let's take a look at number 4. So again, this is part of like your little assignment packet on page 11. And it says that Donna walks home to her dorm from class one day. Everyone's favorite story problems, right? She has to walk 6 blocks north and then 7 blocks east. How much shorter would her walk be if there were a direct path from her class to her dorm? So Donna walks north and then east. Like she has to go up a road and then a road. And they're asking though, so if she has to walk north and then east, how much faster would it be if there was a spot that just went directly there? So how many total blocks is Donna walking right now? How many blocks? What's it say? If she walks 6 blocks north and 7 blocks east, how many blocks is she actually walking right now? Yeah, 13. So right now, Donna's walking 13 blocks total right now. So they want to know how much shorter would it be if there was a direct path. So let's figure this out. So if we have, we're going to do, because this is north, south, east, west, we're going to put it on a coordinate plane. So never eat soggy waffles. Does everyone know about that? Okay, usually there's about one person that I open their mind to. North, south, east, west, never eat soggy waffles. Go clockwise, start at the top. So it says that Donna here, we're going to have Donna start here. So this is, she's walking home from her dorm from class one day. So this is where her class is. So when she walks home, she goes 6 blocks north. 1, 2, 3, 4, 5, 6. She goes here. And then she turns and goes 7 blocks east. 1, 2, 3, 4, 5, 6, 7. So 6 blocks north, 7 blocks east, and this is where Donna ends up. So this is where her dorm is, and this is where her class was. So normally Donna would go up and then over, but they want to know, let's say the school's investing some money and wants to build a easy little shortcut here for her. How much faster would it be, or how many blocks would it be to go straight from the class to the dorm? So without them telling you what to do, they want to know, well, if they want to know what the distance would be then from the class to the dorm directly. Instead of going up and then over, what if we just go straight there? So you're going to need to figure out what the distance is from the class to the dorm, and then we're going to compare how much shorter it actually would be. Because we know the way she's going right now is 13 blocks. We'll see if this is any shorter. So in order to use the distance formula, though, you need coordinates. What's the coordinate for where her class is? Right here, her class. 0, 0. So her class is at 0, 0. And her dorm is at what coordinate? It's not 6, 7. What's this point? It'd be 7, 6. You go left, right, then up or down. So we're going to label my 0, 0 with my x1, y1. My dorm is my x2, y2. It doesn't matter. Actually, you could flip-flop those around. And then we're going to plug into the distance formula. We're going to figure out what the actual distance would be straight from the class to the dorm. So distance would be, let's see here. We've got to plug into this distance formula. 0 minus 7 squared plus 0 minus 6 squared.